Good morning, students. Today we are going to revise one of the important topics which has been regularly asked in the CBSE exams of 10th class, that is refraction of light through a rectangular glass prism of the chapter light. Another name for the same topic is show that incident ray on the glass slab is parallel to the emergent ray, and means board exam asked the similar topic in two or three different ways. So two different ways in which the board exam asks or CBSE board asking this diagram or this topic is given in the is given here. So to understand this topic, first of all we must know the rules of the refraction of light. First of all we must know what is a refraction of light. Refraction of light is the phenomena in which the light bends, and when it moves from the one medium to the another medium. Okay, so first of all we must know these rules of refraction of light. That means when a light moves from a rarer medium to a denser medium, and what will happen when the light moves from a denser medium to a rarer medium. Okay, so first of all we will see that whenever a light moves from a rarer medium to a denser medium, we define rarer medium and denser medium according to the speed of light in those mediums. Means if it is a rarer medium, so the speed of light will be more. If it will be a denser medium, that means the speed of light in that particular medium will be lesser. So I have drawn the interface of the rarer medium and denser medium, and according to that interface I have drawn a normal. Now when we incident a ray of light, suppose we incident a ray of light like this, and it is moving from a rarer medium to a denser medium. Now if we will draw the original path, that means if there will no refraction of light, this ray will move like this. But since it is moving from a rarer medium to a denser medium and there will be a change in the speed of light, refraction will take place. And that refraction, what it will do, it will bend this light, and the refraction will bend this light toward the normal. Means the original path through which the light has to travel will be this one, but due to the refraction of light and due to a different medium, the light has bent, and it has bent toward the normal. Okay, it has bent towards the normal. Okay, just opposite to that happens when the light travels from a denser medium to a rarer medium. Now again, if we draw a incident ray, this is the incident ray. So if there will be no refraction of light, then this ray will travel like this. But since it is moving from a denser medium to a rarer medium, what will happen? This ray of light will move away from the normal, just like this. Okay, now these two rules we will use to make the diagram for this refraction of light through a rectangular glass slab. Okay, now ABCD is a rectangular glass slab. It is a 3D shape. You can think of a cuboid in which the refracting surfaces are of rectangular shape. It contains two refracting surfaces, one is AB and one is CD, which are parallel to each other. Okay, I have written here refracting surfaces, and both these refracting surfaces will be parallel to each other. Now this is the medium air, which is a rarer medium. This is glass. This rectangular glass slab is made up of glass. It is a denser medium as compared to the air, and again this is air. Now when we incident a ray of light on this glass slab. This is the incident ray. This is the incident ray, means the ray of light which strikes the glass surface, the rectangular glass slab, is the incident ray. Okay, and this is the normal. What is normal? It is an imaginary line which is always perpendicular to the surface. Okay, if this is the surface, then this perpendicular line to this surface will be the normal. Okay, the angle between this normal and incident ray is known as angle of incidence, angle I. Okay, now this ray is moving from a rarer medium to a denser medium, so we will use this rule that whenever a ray of light moves from a rarer medium to a denser medium, it will move towards the normal. Now you can see this is the original path, the red line is the original path of the incident ray, and when it moves from a rarer medium to a denser medium, it bends towards the normal. Okay, so this is the refracted ray, we will say. This is the refracted ray, and the angle between the normal and the refracted ray is known as angle of refraction. Okay, now this is interface 1 and this is interface 2. Means when this refracted ray reaches at the interface 2, it has to move from a denser medium to a rarer medium. Okay, if we will look at the original path of this is the original path of this refracted ray. This is the normal, and now it has to move from a denser medium to a rarer medium. So we will use this law, that when a ray of light moves from a denser medium to a rarer medium, it will move away from the normal, from its original path. So as you can see, this is the original path and it has moved away from the normal. Okay, this will be the angle of emergence. This is the emergent ray. What is emergent ray? The ray of light, which will come out of the glass slab after refraction, is known as emergent ray, and the angle between the normal and the emergent ray is known as angle of emergence. Okay, now if you will extend the incident ray, the original path of the incident ray, and if you will extend the original path of the incident ray and you will draw the emergent ray, you can see these two rays will be parallel to each other. That means if you will find out the perpendicular distance between these two, that will be equal. Okay, that will be equal. That means this incident ray and this emergent ray will be parallel to each other. Okay, so with the help of this diagram, we have shown that the incident ray and the emergent ray are parallel to each other. Now if you will notice, this incident ray has to move through this path, but now after refraction through the glass slab, it is moving to from this path. That means it has shifted sideways. Okay, this ray of light has shifted sideways. This phenomena of shifting of the incident ray of light sideways is known as lateral displacement. Lateral displacement, or it is known as lateral shift. Okay, thank you and have a nice day.